Chapter 8, Unit 4. Let's talk about directional or a one-tail hypothesis test. In a directional hypothesis test, or more commonly called a one-tail test, the hypotheses specify either an increase or a decrease in the population mean. So they make a statement about the direction or the effect. So here's what the hypotheses would look like. You would have a null hypothesis. Basically, there would be no difference or change. The treatment does not work. Or you'd have a research hypothesis, which says there is a significant difference or change. The treatment does work. So let's look at an example of a one-tail test. A research study examined the effect of waitresses wearing red on the tips given by male customers. In the study, each participant in a sample of 36 was served by a waitress wearing a red shirt, and the size of the tip was recorded. For the general population of male customers, those served by waitresses without a red shirt, the distribution of tips was roughly normal with a mean of 16% and a standard deviation of 3 percentage points. In this example, the researcher expects that the color red will increase tips. If the researcher obtains a sample mean of m equals 16.9% for 36 participants, is the result sufficient to conclude that the red shirt really increases tips? Step 1, you're going to write the hypotheses. Since the direction is given, in this case an increase, we're going to use a hypothesis for a one-tail test. When you write the hypothesis for a test, you always write the research hypothesis first. So you would write H1, and the researcher expects that they will increase, so you would say mean is greater than 16. And then you would write the null hypothesis, HO, to be the opposite of that. In this case, the opposite of greater than would be less than or equal to 16. So here's your picture. You have a one-tail test. Let's look up the criteria. So the alpha level gives the probability for the tail in this case. Since the alpha level is 0.05, the probability is 0.05. There's no need to divide it in two. There's not two tails. There's only one tail. So the entire alpha level is the probability you look up in your tables. When you look that up, you find a z-score equal to 1.65. You're going to draw your line on the picture. You're going to label your cutoff score. In this case, it's a positive 1.65, and you're going to shade in the area, which will be your rejection region. The next thing you're going to do is compute your sample statistics. You're going to find that the error is going to be equal to 0.5, and you're going to calculate a z-score, and that's going to be 1.8. And then you're going to make a table using that standard error of 0.5. So make your table, put it underneath your graph. The next thing you're going to do is make a decision. Well, the calculated z-score is 1.8, so put an X on the graph where the 1.8 is. Since it's in the rejection region, you're going to reject the null hypothesis, and you're going to say there is a significant treatment effect. So your conclusion sentence would be, wearing a red shirt produced a significant increase in tips. Z is equal to 1.8. The probability is less than 0.05, and it's a one-tail test. Let's look at learning check problem 1. See if you can solve this. A population is known to have a mean of 45. A treatment is expected to increase scores for individuals in this population. If the treatment is evaluated using a one-tail hypothesis, then which is the correct statement for the null hypothesis? Well, remember we do the research hypothesis first, and the research here says that it's expected to increase scores. So the research hypothesis was mean is greater than 45. The null hypothesis is the opposite, which would be mean is less than or equal to 45. And this is what your graph would look like, and there's your answer right there. So basically the null hypothesis is the body. It's everybody on the left side of this graph, so it's less than or equal to 45. Learning check problem 2. A researcher is conducting an experiment to evaluate a treatment that is expected to decrease the scores for individuals in a population that is known to have a mean of 95. The results will be examined using a one-tail hypothesis test. Which of the following is the correct statement of the alternative hypothesis H1, which we also call the research hypothesis? So in this example, the researcher is expecting the scores to decrease. So your research hypothesis or alternate hypothesis would be the mean is less than 95 because you are expecting a decrease. This is what your picture would look like, and that is what your research hypothesis would look like. Learning check problem 3. A researcher expects a treatment to produce an increase in the population mean. Assuming a normal distribution, what is the critical z-score for a one-tail test with alpha equal 0.01? Again, you're going to look up a p-value of 0.01 because it's a one-tail test, and you're going to find a z-score equal to 2.33, and that will be your critical z-score.